Hey, this is Matt Wimmer from Brody Precision. In this video, we're taking a look at the 60-minute segment that aired this past week about healthy buildings, and we're going to try to distill a lot of the really good information that was in that video down into a much shorter format that we like to produce here on the YouTube channel. So let's jump in and take a look. So the first two things I wanted to cite was the scientific papers that are mentioned in the video. Weirdly, I didn't seem to find any links directly on their website, so I grabbed the papers themselves and linked them here, and this PowerPoint presentation as well as these links will be available down in the comments below, so you can have a look at them. So let's get to the meat of this. The main takeaways from this video, I guess if we take a step back further, why all of this really matters. Occupancy rates in commercial buildings are lower than they were before, much lower than they were before, which means that there's more competition between building owners. So you want to have the best offering for your potential tenants. So the way to do that from our perspective is to make the building healthier when it comes to the air that's in it and what we can control. So the first thing that we can do for that is to increase the air exchange rates. Typically, you're only looking at a few per hour, per air exchanges per hour. We want to be targeting at least 4 to 6, ideally. Something like an airplane. As I was researching this, I found this. Something like a plane, a typical commercial jet, will do something like 20 air exchanges per hour. We don't need to hit that number, but we do want to get 4 to 6-ish. Obviously, more air exchanges that you do, more outside air, fresh air you're going to bring in, and the more air that's going to go across your filters and the more filtering you're going to do. So on the filtering side of things, we can also do a better job. We can target MERV 13 plus or more MERV 13 or above for our filters that we're using. A typical commercial filter is only going to be a MERV 8. So if we look over here in the chart, MERV 8, we're mostly just trapping particles that are larger, so 3 to 10 microns. But when we jump up to something like a MERV 13, we're trapping most of our anything 1 micron and larger we're trapping. And then we're also doing a decent job at the even smaller particles like 0.3 to 1 micron. And then obviously as you go up higher in those MERV ratings, you're trapping more and more. Your HEPA filters and things like that are like MERV 17 and above, things that you'll typically see in like operating rooms and that kind of thing. The next thing that we can do is use our sensor data that we have and take a look at things like our CO2 and use that as an indication of the air health. Every person that's in a building is going to be breathing, obviously, and you breathe out CO2, and that CO2 can build up in the building as there are more and more people in the building. If you're not getting those air exchange rates as you should and you're not bringing in the outside air that you should be. So we want to be targeting below 800 parts per million. Anything above that, normally like above 1,000 parts per million, you start to actually see some, there's some studies that you see some cognitive effects because of that CO2 built up in the building. So 800 and below is what we're looking for. And then the last piece of that sensor data that we can also make use of, and this one you'll see less of right now. I think it's becoming more and more popular to measure this, but is PM 2.5, so particulate matter 2.5. And we can use that as an indicator of both outdoor air health and indoor air health. Recently, you probably saw in the news, and just breathing here on the East Coast of the U.S., the air quality was super, super bad outside because of the fires in Canada and the air coming down from that. All of those ratings that you were seeing, those numbers that we were getting related to the air quality outside were these particulate matter numbers. So we want to be targeting less than 50 This is a parts per billion. Typically, you won't even see them mention a unit, but it is parts per billion, and you want to be below 50. So on the implementation side, the part that we control, right? I grabbed a couple screenshots here from the 60 Minutes segment and of the actual controls things that I saw in the video. So first, I'll mention these ones at the bottom. Niagara, highlighted here a couple times. The system that they were using and highlighting as a healthy building was all Niagara in the back end. You can see the user interface that's built into Niagara 4 here on the left-hand side. And then these are the KitPX SVG graphics for the unit itself. And then for the sensors, they're using AirThink sensors, which I thought was a little bit strange because the AirThink sensors tend to talk to AirThings cloud, and so the integration and implementation into Niagara is a little bit more complicated than I think it needs to be. So we have a product here at Brody that we sell that is kind of perfect for this kind of thing. It's the TR50-5. There's also a -3, but the -5 is important. There are two models of the -5, a D and an N. D has display, N has no display. And what these are really nice for is that, yes, they measure your temperature, humidity, CO2, your particulate matter, and also your volatile organic compounds. They have an indication on the display for the air quality, so changes colors based on what your air is doing. But the thing that I think is really sweet about them is they're totally agnostic. If you're at all familiar with the Honeywell line, typically the wall sensors have been like silk only for this kind of higher end sensor, which means you can only really use them with Honeywell controllers, spiders. This sensor will also do BACnet and Modbus just from dip switches on the back. So you can use it with literally anything. You're not talking to the cloud. You can talk to any controller you want, any front-end system, so any supervisory controller system. Really, really flexible. I think really, really nice option compared to something like an AirThings that they showed in the video. So that does it for this little breakdown. Hopefully it was informative for you. We'll have some links below in the description, like I mentioned. If you have any questions or comments, leave them in the comments below. And like and subscribe if you haven't already. Thanks for watching, and we'll see you in the next video.